This is Mrs. Schroeder, and we are going to begin covering the section in Chapter 8 called Balancing Chemical Reactions. Our goals today are to talk about conservation of mass and how that relates to a chemical reaction, and learning how to write and interpret balanced chemical reactions. Reactions conserve mass. We know the law of conservation of mass states that matter can never be created or destroyed. It only changes form. It might change from a solid to a liquid or a liquid to a gas, but it does not ever just go away. Following from that, we have to know that the number of atoms must be the same because atoms make up matter. So if we look at a chemical equation, something like CH4 plus oxygen plus CO2 plus water. This is a chemical reaction. It's not balanced yet. How do I know that? I'm going to count the atoms. Carbon on this side equals 1, and there's 1 on the other side. Hydrogen on the reactant side has 4 of them. On the product side, there are 2. Oxygen on the reactant side has 2, and the products have 2 plus 1, 3. Now, is this reaction balanced? No. Right now, we are creating, oxygen is being created, and hydrogen is being destroyed. If this was correct, but we said matter cannot be created or destroyed, so this cannot be correct. We have to find a way to balance an equation. We'll do a couple practice ones tomorrow. So what we want to look at is how do I do it? First step is to count your atoms. What I just did. Is it balanced already? If the answer is no, then we need to change coefficients. What are coefficients? It's the number in front. That's what I change. That coefficient is a multiplier. Not an addition, but a multiplication. It multiplies by how many are in there. For example, if I have H2O, I have 2 hydrogen and 1 oxygen. If I have 2 H2O, I had 2 times 2 equals 4 hydrogen. And 2 times 1, if there's not a number there, it's 1, means I have 2 oxygen atoms. I never change the subscripts. Never change the subscripts. So I can't decide to balance this thing by adding a 2 here, because H2O2 is much different than H2O. H2O2 is hydrogen peroxide, the stuff you put on your cuts in that brown bottle. You don't want to drink it. It's a different material. So you cannot change the subscripts. Change the subscripts, you have a new material. And I don't want a new material, I just want a different number of the material. Sometimes we'll have the even-odd technique. We use this in ionic compounds when I had a +2 and a -3, and I had to multiply them by 3 and by 2 to kind of get things to balance out to a 6 on both sides. Even-odd technique, we'll use that sometimes where we multiply something by a 2 to change to an even number, so we can actually finish our balancing correctly. So an example, count our atoms. Start out with magnesium and nitrogen. Reactant side I have 1, product side I have 3. Reactant side I have 2 nitrogen and 2 nitrogen. Is it balanced? No. What do I have to do? Next step says we're going to change coefficients. If I have 1 magnesium here and 3 over here, I need to have 3 on this side. How do I make it go times 3? I have to put a 3 here. 3 in front of the magnesium gives me 3 here. They're balanced. They check. Nitrogen, I have 2 and 2. It's the same thing. It checks. Okay, that's verifying results. Does it work? Is it correct? If I have a polyatomic ion, remember things from the purple sheet, things that act as a group. When I see it act as a group, it's the same on both sides. What can I do? I can balance it without having to break it apart. Now you could break this apart and balance oxygen and sulfur separately. But if it's the same on both sides, you can actually balance it as a sulfate ion and a sulfate ion. There's 3 of them on this side. I need 3 here. I can also look then, aluminum, I have 2 on this side. I need 2 over here. So I can look at balancing that sulfate ion as a ion just as one thing. Consider it to be one thing. To finish up, again, hydrogen, I have 6 on this side. I have 2 over here. I need a 3 in front of there to balance it. So that would balance on both sides. One more example we're going to try together here. Phosphorus and oxygen. I have a P4 and I have a P2. Right now it's not balanced. I need to multiply by 2 to make it equal 4. So I put my 2 in front of the P2O5. Oxygen, I have 2 on this side. Right now I have 2 times 5. This 2 acts on both the P and the O. So I have 10 oxygen. I need to get to 10 over here. So multiply it by 5 also, which means that 5 has to go in front of the oxygen. So that is how to balance reactions. I balance them because of the law of conservation of mass, as I cannot have matter created or destroyed. Atoms have to be the same for each atom on each side of the equation. When you're done, verify that it actually works out and both atoms are the same for both elements on both sides. We'll do more example problems in class, do some practice with balancing, and get you guys ready to go.